everyone. Thank you for joining us tonight. As he said, as Russ said, my name is Jared McNabb. I'm president of Restoration Organics, and on that business we focus on soil health management. Though we prefer to work with natives and these various habitats, we also do turf and other conventional landscapes too. We also have about 600,000 redworms that we use for vermiculture. So we process a lot of food wastes, plant residues, and turn that into a biological inoculant. And we use that to help rebuild a lot of our soils. Locals is a company that we recently just opened up. We specifically work with wholesale and various organizations to provide restoration-style plantings. So they come in, what you do in plugs, and they do a lot of root pruning and helps to get the plant specifically to the water table for the roots. And today I'm talking about improving your soil function. So soil function mostly has what's labeled as about 5 functions that healthy soil should have. That's habitat, that revolves around any type of organic material, plant residues that are installed or incorporated into the soil itself. If we have any type of soil that's barren, bare soil that does not have any established roots in the system, you simply just have a lot of rock minerals, what you lose is that organic material, microorganisms that will feed on that to continue to build. Then you have, so that comes with the habitat. Physical structure, that ranges from anybody in construction, engineering, to, for a house, to physical structure that you'd be using for supporting roots in itself. Then storage and transportation. With storage, you would be utilizing a lot of water and nutrients that would normally be locked up, but can be released through microorganisms in the soil themselves, with earthworms, your shredders, different types of mites, springtails, and fungi. And nutrient cycling. That's essentially the soil performing composting in itself. It's once living material that has been, that died and is decomposing. And that's how nature naturally repairs and restores a lot of its nutrients. So as you see here, this is a photo. You can see a lot of fungi that's going symbiotically within the root structure from a plant that was dug up. And in itself, they protect. It's a symbiotic relationship. They've seen studies that have shown that so much carbon can be transferred in itself through a network within forest systems from one plant to another through this mycorrhizal network that's there. But what it all starts off as, everybody that has a home, most everybody that has a home, especially within suburbia or any type of urban area, we all start from the same point. And that's due to construction and development. What construction and development does is it scrapes off the topsoil. And even further, they'll take areas, especially in our region, the piney woods, the Gulf Coast prairies, they'll take wetlands that maybe not be registered with the state, but they still support a function, an ecological function. And they'll turn them into things like detention ponds. Seen it happen. It's pretty sad and frightening to see how we have a resource that's out there and it immediately turns into something else. But with these disturbances, it brings the whole system back. You're looking at, though it's not going all the way back, what you would see in primary succession, which generally happens in rock bases, but it does bring it back further than what would happen with fires. So as I was saying before, it's great for engineering and construction, bridges, roads, but not for our soils. This right here, you can see, this is primary succession that happens as the soil in itself evolves and gradually moves from its standard base, its rock base, to over here within a more complex forest system. So whenever development comes in, you have got, it's an in-between of this. Though you're not down to the base rock, you still have quite a bit of soil that's been removed. And even though a lot of developers, what they'll do is they'll stockpile and bring the soil over to the side. But by that point, how fragile that system is, especially mycorrhizae, has been completely destroyed. And then on top of that, you've got to think that with the topsoil and the amount of organic material that's there, organic material and organic matter, what ends up happening is that their metabolic rate in that soil increases rapidly, because now oxygen has increased and gotten to levels that would not normally be there, especially within the top 6 inches, and carbon is being released into the atmosphere. So what you do is so when we have our houses or anything, in a sense that even if the house has been there for a few decades and we still go off the same practices and haven't really focused on improving the soil in itself, we are still right along in this area. And specifically, I'm talking about not using carbon-based amendments. Carbon-based amendments, I'm not talking about, it doesn't have to be specifically organic in the sense of certification and things like that, but most importantly, using natural elements. And that's how you bring these plants back. So we'll go in and tear everything down, or developers will necessarily tear everything down, and guess what goes in your front yard? Trees, right? Why are trees stunted? Why are they taking so long to establish? I mean, the soil ecology in itself plays a huge role in what nutrients are available, the pH, and trying to take something like this where you've got, in a forest system, you have studies that they've shown that there's something that they would use as a hub tree, a tree that itself that will look over for the rest of the trees, especially trees, younger seedlings. It's been able to identify its younger seedlings, and they've been able to test this out through carbon-13 and carbon-14, through radioactive materials, and be able to notice that it's been able to transfer, especially whenever there's terms of stress. It's been able to transfer its carbon down to its seedlings to help prosper young plants. So with that, you have problems with vegetation growing. Vegetation having problem growing, you have bare soil. So bare soil, you've got erosion. And it goes, depending upon the elements that are there, whether it's wind or water, it can go from anywhere from about 10 times its rate of erosion to about 1,000 times the rate. And also runoff. So we go out and we apply our nutrients, regardless if it's synthetics or organics or anything else like that in that manner. If those nutrients still are readily available, even if you put out fish hydrolysate or anything that's in a liquid form, if that soil cannot retain those nutrients, it will leach it off. And we have poor infiltration. So that's common through our parts. And a lot of problems is people continue to try to increase the growth of the grass. So putting out fertilizers and things like that. But then the problem is it's not able to infiltrate through that area, and it will continue to run off. So it's left with what I classify as 2 options. You can either make lemonade, so that means you could take that situation like you have right here and say, okay, what we're going to do is we're not going to address the soil. We're going to go in and take a cut out of this area, remove that vegetation that's there, and put plants that would establish and be able to thrive and take off and make a bed from that. So you're mostly looking at something that would deal seasonally with the amount of inundation, like wetlands. You could use various emergents, Juncus epiphysis, which is soft rush, and Eliocharis, so any of your spike rushes work fantastic in that. And a way to be able to collect that to make sure that those plants are continuing to get the amount of hydration that they need, you can even create even more of a depression. So you can turn something like this into a beautiful bed. Then the other option is if, say, you want to be able to have a wildflower garden that is more for your upland species, then you have to go in and amend the soil. You can do anything as not as invasive as core aeration and then apply compost into that, or you can go in and simply just And I recommend this only for areas that are more of your new developments. You recently purchased a house or an area, you had some sort of construction that destroyed that soil ecology, that you would go in and incorporate. So that means that you would till organic material and plant residues into that soil. So you would not only just be putting compost in, finished compost, but other plant residues so that you have varying forms of organic pools. And the reason why you do that is because you have three main forms of organic pools. You have you have active, which is mostly a lot of your fresh materials. And those fresh materials is going to have the higher metabolic rate, and it's actually going to increase the amount of polysaccharides in your soil. And that's a big thing, especially when you're trying to repair these soils themselves, especially with infiltration issues. So what we like to focus on is planting for habitat. So when you have something like this, and this is a detention area, and if you're planting for habitat, you've not only just been planting for habitat, you've just increased fishing. Reason being, a lot of these emergents in this area, right over here, your Sagittaria, right here, it looks like the Gramineae that's on this area. This is the Elaeocharis quadrilancata, and some of your Juncus, the soft rushes. And what that does is that provides habitat for invertebrates. You can't just necessarily be thinking on the sense of birds or on your macro scale, because what's going to bring birds there? It's not necessarily going to be your feeders. It's going to be the plants that are there, because a lot of them are omnivore or insectivores, so they're going to be feeding on those insects. What's going to bring those insects in? The various plants. So whenever you build this area up along, you're working on multiple layers. And whenever you build these areas up, you've got various aquatic invertebrates and periphyton, which is a grouping of algae and bacteria. They're going to help decompose a lot of this material. And this is another practice too. So if you have an area that floods a lot, you can use that, especially within a corridor, a utility corridor, gas line, any type of area that has an issue with drainage. And this right here is your Juncus effusus. And then you have the importance of placement. So I just recently took this because we were going over to this professional building right over here, and minus the blue airplane toilet water that's coming out of this, still don't understand why that's appealing. And actually, when you walk by, I don't know if you guys have ever been there, but this is right off 290. I think it's Cypress Forest Professional Building. And when you walk by, all it takes is just the slightest breeze, and then you get splashed and peppered with this wonderful blue water. So what they've done is they recently did an installation of these plants. Now, I found out what this was. And it was an iris family, but I found out that it was a Louisiana iris, which actually isn't native to our area. But they were planting these right here, more of a cultivar, and all they had, and they put irrigation all in this area, which blows my mind, because you move it 6-8 feet right here, and that plant is going to thrive, because you're not having to deal with much with wave attenuation, because this is a standard pond. Yes, they have a fountain right here, but it's not going to be affecting the level at which this iris will just take off and really just encompass this area right here. And this will be a wonderful habitat. But then again, I don't know what that blue water is. But it's a matter of knowing how you can adjust to the situation. So, you know, within communities, and some of you guys might live in one of them, that you notice that there'll be berms that they'll have along maybe the entrance or throughout the community common areas, and they'll put landscapes, just various beds on top of those, and then they'll start trying to shoot water on top of that. Once again, you can take something that's sitting on top of a berm and say, yes, you want to have berms just be able to provide as a structure. Maybe it's a barrier, some sort of partition. But if you simply move that landscape bed at the bottom of it, and you turn a landscape bed that's sitting on top of a hill, you just flip it upside down, and now you have a catchment for water. So then you don't have to worry about irrigation, especially if you're using the right native plants. It's just changing the way that we generally think. Immediately within developments, when we see plans and look at it, it's okay, the irrigation is going to go here. Well, we've gotten so used to dealing with irrigation that we haven't thought that, and remembered that it's actually supposed to be supplemental, and it was supplemental to deal with a lot of these non-natives. So much water can be preserved by simply just adjusting where we're putting these plants, and maybe even instead of having these massive raised beds that you'll see about a foot above ground, and recessing them. This is a great diagram that shows the general idea of how, for which plants you would rate for hydrology. With any type of plants, I would recommend, especially if you're selecting based on water, I would look at what the Army Corps of Engineers had identified on their main 5 levels of wetland identification for plants. And you have your obligates, which is year-round, they're inundated. Then you have your facultative wetlands, that goes to the next level up. Then what you would have is your facultative plants, then the FACU, which is the facultative upland, and then you have your upland species. And your upland species on that spectrum essentially just rarely would never see, it's above what would be a floodplain. It would rarely see water, and flood inundation levels. And so using something like this is a great guide that can be used for your homes or within your communities to identify what plants could we use within this area based on the amount of rainfall that we have and where this water is collecting. So, for instance, this community right here, when it rains a couple inches, this is what happens. So all this water is running off, or it's staying on this gas line, pipeline corridor, and mosquitoes are atrocious. That's one of the worst things in Houston is the mosquitoes. So you've created a breeding habit. With something like this, you could go in and know where, because of how long this corridor is, you could use areas where you have permanent pools. And by having permanent pools, by creating berms, what you do is replicating wetland areas, you would be able to have various predators that would be able to inhabit these places. So you would have like gambusia fish, though it's a non-native, it's everywhere. But gambusia is your mosquito fish, and they are voracious eaters. So being able to have something like that where you can control the hydrology is a huge component to have. Then also you don't have to worry about all of this runoff and all this water that's sitting above the surface. For the areas that are not the permanent pool, we could be replenishing our aquifers. We could put it back into the groundwater. That is a massive problem. It is going to be, I mean, if you look at it, I was recently listening to someone that was talking to me about the price of water and how a gallon of water is actually far more expensive than a gallon of gas. If you go to the grocery store and you just buy, what is it, like a 12-ounce bottle of water, you go in and you grab it, I mean, how much is that right now? It's almost $2. It's probably $1.50 sometimes. And you think about that and comparing that to how much it is for a gallon of gas, it's going to be a massive problem, especially whenever we are working with the water that we have right now. We're not going to get any more, we're not going to get any less, but the problem is we're going to have to treat this water, especially if it's all out into our Gulf. So what we can do is by replenishing our aquifers and be able to have that, we can help reduce or combat a lot of this new development that's going out and be able to reduce some of these costs because the cost is going to go skyrocketing. So a solution, you have your swales. So you can turn something that would be, this is not the same project, this is just an area that I saw and this is a solution. Based on, you're taking what would be a vegetative swale and you're putting plants that would be along the same hydrology level, the zone that would fit for those plants, and you're installing them there and allowing them to take off. You can even have buffers along this area where you're using your common Bermuda grasses and things like that that would be able to fill up this area. And it would look great, especially with seasonal interest. And that's the great thing whenever either if you're seeding or you're planting out, you put in plants that will provide a buffer. So by that I mean say it becomes, we have more of a drought in the summertime, then some of the plants that require a little bit more water would either go dormant or die back, but then you have other backup species that would be able to take over and flourish this area because, as I mentioned before, one of the worst things that you can have is bare soil. You do not want to have bare soil. Other properties, especially out in the piney woods areas. Some of them are noticed as you drive around. You can see that they're trying to keep some of the woods and the piney woods that are around this area and some of that ecosystem. But the problem is when they go out and they try to clear out a lot of your understory, you leave this open, and nature doesn't work like that. You need your understory plantings. You need your various ferns. You need, depending upon the habitat. You need your grasses in there, your forbs, to be able to still, because their root systems are going to be able to penetrate that soil deeper, and so they're going to help replenish that soil level rather than within a lot of the trees. So what will end up happening is a lot of this will start eroding away, and then you'll start noticing a decline of a lot of the tree species, woody species there. And it's going to cost them far more to be able to fix that. You're always in a better situation and much cheaper situation to address a problem like this as quickly as you can. And this is essentially, this is over in a longleaf pine area that's like close to Nacogdoches, but these are species that grow here. And especially with throwing out, with something like this, I would recommend in this area putting out, yes, some annuals, but the problem with annuals is that if you're also trying to grow perennials, that they're going to take up a lot of that space, and some of the space that you would need, especially in the open tree line, which would normally be like within our savanna areas, you're going to have vegetation that still requires sunlight, requires heat to be able to germinate, and so you won't be able to get those because you'll have a lot of annuals there. And especially with the fact that this is a wooded area, so you have a lot of fungally dominated species. Throwing down annuals is not going to be the best way to go. You're going to be consistently combating that. The fungi that normally would be breaking down a lot of this material, lignin-based material, really hard to break down material, they release ammonium nitrate. Rather than with bacteria, you mostly get a lot of your nitrate. So whenever you change from the ecology of the soil, let me see if I can get like this, you're changing, this is more of a nitrate-based soil, and as it goes a little bit further and more fungally dominated soil, you're getting a different form of nitrogen, and it's ammonium nitrate. And that's the soil in itself, a combination with the soil and the vegetation depicts how quickly you have your successional growth. But that was the last slide with the photo. Most important is identifying a lot of these areas. We're starting to see a little bit more of an increase of developers that are trying to keep a more natural look. I noticed that within people that I've spoken with that it's been a common question that people worry about is maybe snakes or other species that I guess you would cause problematic. But if you think about it this way, to answer the question about with species or the concern about that with snakes is snakes are predators. So they're going to be thinning the herd, especially within rodents and mice. So if you take out one predator, you've got more of an issue of your decomposers, your producers. So that's an important focus to think about is, where are you going to push and pull from? Keeping these ecological services, especially that we get from wetlands, as the kidneys of the earth. It's important to really think where you want to go with this. What future are you looking for? So that pretty much that's the end of my slide. Does anybody have any questions? Yes. In the back? Yes, ma'am.
I think do you raise plants?
Yes, ma'am.
Do you have a nursery?
Yes, ma'am.
Is it wholesale only?
Yes, ma'am.
Or, okay. And is it possible to find out what you're growing?
Yeah, we are, right now, we're starting our first year. We kind of wrapped up some of the construction. So we've got all of our plants that we grow are either seeds were harvested and collected from the area, so within roughly about 50 miles or so. And we don't sell any nativars, cultivars, species like that, but it's all prairies, wetlands, and woodland species. And they're going to be in plugs or tall growth, like what they would classify as 1 gallons, but 1 gallons truly aren't by volume 1 gallon. But we would like to be able to get to the point where we sell retail as well. But I can look at getting you a list and putting that out to see what we have.
Yeah, that'd be great. Thank you.
Have you
Yes.
ever had any experience with biochar?
I haven't worked with biochar.
Yeah.
Yeah, from my understanding of the process of making biochar, there is a clear definition of a right way and a wrong way to do it. But yet there's no regulations on what is good biochar and what is not. So I've generally tried to stay away from that. A lot of the materials that we stick with are repurposed from sites. So if we work with a developer, what we're doing is when they're doing their tree clearing, we're using a lot of those materials that normally go and be hauled off and trying to keep them on site. So with something like that, I haven't used.
Yeah, I was just wondering, on a small scale like you have in a residential development, you actually can't burn your lot, right?
Right.
But you can on prairie, and it stimulates a lot of growth. And I'm wondering if you carry over what you could do on a residential piece of property, is biochar something that would give you that kind of vitality in native plants that you get from burning the prairie? Is it similar in concept?
It's a good thought. My understanding, especially with species that require some sort of heat stratification, is based on temperature or the smoke in itself. There's a way to stratify by using some of the smoke from leaf debris. But as of the biochar, I'm not sure how that would affect. My understanding with biochar and using that is for the humus level, to be able to store and retain a lot of the water and the nutrients.
Because I've read a lot about it, but I'm trying to piece it together now.
Yes?
So in prairie area, you have more bacteria.
It's a balance.
And then in the forest, you have more fungal base.
Yes.
And the bacteria is producing more nitrates, and the fungi produce more
Ammonium nitrate.
ammonium nitrates.
Mm-hmm.
Okay.
Yes. Or ammonium based. Yes. Yeah. Yes.
And you mentioned that, when developers come in and clear a bunch of stuff, you try to keep a lot of the material on site. Are you chipping it or composting it or keeping it on site?
Chipping it, depending upon what's there. If there's a lot of deciduous detritus, like plant leaves and things like that, then what we'll do is we can make a blend, then allow it to kind of sit on the side for a little bit, mix it in with some of their topsoil, and really find essentially we're composting with their soil. Whenever you put fresh material, what you can do is you're increasing the amount of the higher metabolic rate that's there, and you're actually at a faster rate, you're increasing or improving the soil structure because of the activity. So it's a balance. If there's a little bit of time to be able to utilize those materials, we definitely be able to do it. It's something that needs to be incorporated right away and they want to be planting right after that, then that's where you fall into the issues. Some things that we found that works well is by using what happens whenever you put too high carbon material out there and you incorporate that into your soil, you normally have a mobilization of nitrogen, which generally can be an issue. But what we've seen whenever you do that with that method, you help resist a lot of the non-natives that are there and allow the natives that do not require that high amount of nitrogen to be able to kind of take off and kind of get a little bit of a head start. And leaves are fantastic. Probably one of the best composts. But anytime you want to, just one second, anytime you want to improve some of these areas, what I recommend is based on the vegetation that you're trying to grow incorporate that type of plant residue into the soil. Yes?
So, a lot of the banks of the bayous are grassy, they put some wildflowers on them now. And they're mowed because their concept, I think, is that they don't want obstructions. But it seems to me that the soil and infiltration would be better if you had more like a prairie type grass.
Yes, not only just because of the structure of the roots, the density, because you have various native plants, native grasses will have maybe longer roots, but they have less biomass underneath. But that's why it's important to have a good diversity. But yes, with like common Bermuda, which you see seeded out all the time, that root system is nowhere compared to where it could be with, I mean, you're looking at a few inches versus feet, tens of feet that could be used with native grasses.
And you know, if I guess if the county or the Corps of Engineers, whoever maintains the bayous, do they ever even look at that, or are they just looking at it through their own tunnel vision, like they just want to keep it clear?
Well, what engineers do whenever they're designing a lot of these channels is how quickly can this water be moved from point A to point B. And it's not as much in the sense of infiltration or what water can be stored, it's just how quickly can that water be moved. So that's the difference. There's something called a Manny's coefficient, where they take the different types of structures. So when you have a lot of concrete or riprap, it has a certain value to it, and it affects about how much it can slow the water down. So if you're slowing the water down too much and the channel's not set for it, then when you have your bank full, essentially where the top of bank is at, you can have an overflow. So you've changed the volume of water that can be held in that area. Now with grasses, just by simply allowing it to grow at a taller height, that improves. That improves the structure of the soil and what it can hold on to, because it's the roots themselves. Especially with mowings too, and how they do it, and how often they're changing it up, and what blade height they're cutting. Whenever you have a taller, mature grass, so you have, I mean, even with like little blue stem or big blue stem, and you come in and you cut that down from a full mature height to a few inches on the ground, what you've done is not only have you essentially caused it to die off all of its roots at the bottom. It cuts off all the nutrients down to how far it extends to, and then roughly about how much you cut off is roughly how much is killing back from the roots themselves. And then the problem is it's now stressed, so it takes longer for it to recover. So that's why whenever you're mowing prairie grasses or forbs, those types of flora, what you want to do is based on how mature they are, you only want to go down to about a foot above the grade, above the soil level. That affects it. So whenever they mow those grasses and they come in and they just chop it down, maybe they do quarterly mowings, that's impacted the root structure big time.
Does anybody go in and cut at a foot? I mean, do people do that sort of thing?
When they go in and they mow that, yeah, when they mow those banks, no, they're cutting it back. Because a lot of times what people will say is, it looks unkempt, it needs to be mowed, why has this not been maintained? People worry about snakes and other things, then they'll go in and just hack it down.
If say you have, basically our good gumbo black soil, don't call it soil, it's clay. How do you work with that, or how do you try to amend that? What would be your kind of a recipe, or what would be your formula for working with that soil?
To help aerate it, if you want to be able to, the easiest way of doing that is being able to put down leaf debris, composts, a little bit more expensive side, but something to where you're not fully smothering it, but you're putting down about 1/2 inch or so on top of those areas. If you're talking specifically like your turf grasses?
No, I'm saying, any residential lot, 50 by 100, for example.
Oh, okay.
That's been here for a while, since the 1930s, almost has no soil. It just has, everything's run off and you just have clay. And then maybe if you built a new house on there, they may bring some builder's grade stuff and spread it out.
Yeah.
But there's like 6 inches of that, and then you got clay. So if you want something that really wants to get down inside there, assume you could help it by trying to open it up, add some material. I'd even use sand.
No, sand and clay make concrete.
Yeah, okay, well,
Yeah. So,
throw something else in there too.
yeah. So compost is a great way to do it. You can work from the top down, so by doing top dressings, or you can, and then making sure that you have vegetation there. As quickly as you can get vegetation in that area, the more exudates, the more sugars that are being released from those plants that are feeding the microbes and essentially just cow calling all those microbes that come in and start feeding off of that. That's whenever you're going to get the bigger impacts. The other way to do it is you are incorporating material into that clay soil, especially gray soil, gray clay. You incorporating a percentage of mulches inside, like hardwood wood chips. And especially if it's an area that maybe you're going to have a little bit more foot traffic, pea gravel or anything else that's more of an inorganic but permanent structure to it. What that's going to do is help combat some of the compaction that's going to be there.
Or I can just call Margaret and say, what do I plant in black clay or gray clay?
Yeah, that works.
She's an expert at it.
Yes.
Along those same lines, my oak tree dropped a huge quantity of leaves this year, and I've got, those big blue bins for garbage.
Mm-hmm.
I've filled mine up 4 times. And I had my yard guy mow them, and so they're chipped. So I'm wondering, okay, now what do I use that for? Would that be good to, say, spread over the yard?
Door prizes.
Yeah.
What's it good for?
Is it a live oak? What type of? Yeah. So it has a really high carbon to nitrogen ratio. So if there's any way to increase surface area, so shrink the size of the particulates that are there. So if you have them in trash bags or trash bins.
No. I put them in the backyard in piles, and I had my yard guy mow over them. So
Okay.
They're all chopped up.
So they're all chipped
Yes.
fine, and so it's still in a,
A pile.
kind of a pile.
The smaller you can make those particles, the faster. Yeah, people will put them in trash bins. That's what I thought you said, trash bin.
No, I used them to carry them from the front yard to the back.
Oh, okay.
So it's already pretty well chopped up stuff.
Yeah. No, I knew. I heard you say that.
I picked them up from the front yard, put them in the garbage bin, pulled them to the backyard, dumped it out, went back, got some more, etc. And then once I had this huge, humongous pile, I got the yard guy, because I don't have a lawnmower, I got the yard guy to mow over it and chip them up real good.
Yeah.
So they're just kind of sitting there, and I'm looking at them wondering, okay, now what do I do with them?
If you want to spend a little bit more time on it, you can always rake them together. And that's what I was saying, putting them in some sort of container. And if you have, well, if the yard guy's there, maybe the next time that he comes back around, I guarantee you that those leaves are not going to change. That you have him stick the weed eater inside some sort of container. And as it goes down, it's going to chop it up even finer. So it's contained rather than when he puts the blade, because sometimes when they use the blade and they cut across, the turbulence is causing it to flip. And so it's not always cutting it. Any way that you can kind of keep it contained, and then allow him to be able to stick the string trimmer inside and break that up.
This guy's really going to think you're going off the deep end.
So otherwise, if you want to be able to use it, it always makes a mulch. I mean, you can always, but chipping it up and decreasing the size of the particles is going to be, especially with something like live oak leaves, is going to make a big difference.
Can you add anything like in compost to help?
Oh, absolutely. I wouldn't recommend fruits. Fruits are right along what you would classify between cold and hot. Roughly, it's somewhere between 30, 32, 35 carbon and nitrogen ratio. And so it's not hot enough, and they don't provide a whole lot of nutrients to an area because the majority of them are water-based. So, and also they will attract a lot of flies. So if you are going to mix it with it, a high based nitrogen, low carbon, higher nitrogen ratio is going to be your grass clippings. But I'm assuming you probably already have your grass clippings blown onto your.
No.
Yes. Okay. Yeah. You keep them there. Okay. Yeah. So, do you have any animals? Rabbits.
I have feral cats that my neighbor feeds.
We can't hear everything back.
Oh, sorry. She was asking about live oaks, and so she was trying to figure out what to do, and she just told me she has feral cats. So, yeah, that's always.
Feral possums, raccoons, anything that likes that.
I'm sure they would love to take this from you, or love for you to come and take this from them. Going to any type of nonprofit animal rescue, where they have hamsters, gerbils, rabbits, something that's an herbivore, especially something like that. It doesn't have to go through a hot composting process, so you don't have to worry about E. coli, fecal coliform, things like that. You can use that. That is high in nitrogen. Take their bedding that they have and use that and mix it up. They will be happy. That'd be much better than sitting in a black bag and being taken over to the landfill, because it's just going to sit there and it's not going to decompose.
Somebody gave me llama poop once, and it was great.
Oh yeah, it is. Really is. Yeah. I'm sorry. Yes.
Go ahead. Oh, sorry. I was wondering, like, besides, I think, like, the obvious flood mitigation that this could create, I was wondering if you think there might be potential for using this method to, like, restore toxic soils on, like, Superfund sites, areas where there was a lot of toxic waste that depleted the soils in there.
Yes. A lot of processes being used is like microfiltration. We have a project where we've installed bioswales that are attached, that are curb cutouts. So we've got, so if you, along your health strip, generally everybody know what I'm talking about when I say health strip, the area that's from your curb to your sidewalk, called health strip because it's held to keep the grass green there. That area, we've cut those areas out and used retaining walls and engineered soil so that whenever, and had cutouts so that whenever water would flow, it would flow into these cells and be able to process through that. So that it's a similar method what you're talking about. Like microfiltration, you're using fungi to be able to break these down. Now the only issue with those, everything has its limitations, and that's with metals. So heavy metals, it's just going to be, it's going to continue to stay in the soil, and then if anything's growing there, especially any type of produce or anything else like that, it's going to be carried into the produce.
Are there plants that you're aware of that could perhaps pull those metals out?
Oh yeah, they're accumulators, absolutely. And some are non-native here, like alligator weed is an accumulator. But it's something that has to be, you would have to have some sort of monitoring that's set up and a continual harvest of that material until you find out that it's gone. But then again, is where are you putting that? Especially if it goes to the landfill, then again, you've got that area, and now you're actually putting the metals back into the water. Did I answer your question though? Yes. Okay. Yes.
Early on, I think you started to say there were three kinds of organics. There was active and then...
So active, stable, and labelable. So you've got those three main. So you've got like your organic matter that has been decomposed to almost to its furthest point, your humus. And then you have like your active, so that's more of, it's a transition from your actives on one side of the spectrum and then your humus is on the other side. And in between, more of your stable is like maybe roots, dead roots, that type of material. So you have various forms of organic material and organic pools.
So the third category is what?
So you have label. Mm-hmm. It's yeah. Yes. And then, yeah, so you have the active and, yes.
I know there is controversy in terms of the microbiome in the soil, to till or not to till.
Yes, so I recommend tilling on new development. The reason being that destruction's already been done. With soil that's had some sort of vegetation that's there, I recommend going the top-down method. So any ways that you can be able to increase photosynthesis and improve that, then if you're increasing photosynthesis, you're increasing the amount of sugars, the exudates that are being released into the soil. But anytime that you till, and if there's any organic material that's there, that's being metabolized and carbon's being released. And you're going back to what I was talking about. You're going back from your primary succession or your secondary succession. So you're starting back over again. But that's what they have to do with brachias. I'm not sure. I'm a little off on like your broccolis, brassicas. Is that what it was? Yes. Thank you, brassicas. Yeah. So because it cannot have any type of fungally dominated soil, it's got to be extremely bacterial. They need those nitrogens and those readily available minerals that you would get from a bacterial dominated soil. So they'll actually till it up to beat it up and knock off any fungus.
Tell you what, why don't we call a little time out? Any last question that didn't get answered? We got one over there. Okay. One more.
Jared,
Yes.
can you talk about vermicomposting a little bit?
Yeah, vermicomposting. So does anybody know what vermicomposting is? Worms, yes. Yes. So vermicomposting, you're processing plant residues and you're getting a biological fertilizer. The great thing about earthworms, specifically in your more bacterial dominated or your fungal bacterial areas like your prairies and things like that, is that it's taking nutrients from mined areas and you're bringing it back up to the surface. So with specific tunnel dwelling earthworms, they're depositing their cast at the top. They can be identified, they kind of look like ant mounds. And when the rain happens, it will wash it away and put the nutrients back into the soil. So what we're doing is with vermicomposting, you're taking what would normally go to landfills and you're allowing this composting process. It has about 5 times the amount of nitrogen, 7 times the amount of phosphorus, phosphates, and 11 times more potassium that you would get in healthy soil. So it's a very concentrated form of compost. And it doesn't go through a thermophilic process, but the earthworms have been shown that they can even break down a lot of E. coli and various bacteria that would be harmful. So they're moving these microorganisms around essentially like a bus station or a train station, and that's what they do within the soil. We take those and we make extracts. So we'll take out and wash off all of the beneficial microorganisms, humus content, and spray this out into areas that have been recently developed on or disturbed. And they're great for in that area, but the problem is there is, especially up in the northern part of the United States, there's an invasion of earthworms that are not from here. They're from China and I can't remember the other continent where it's from, the other country where it's from, but they've actually started to take down and destroy some of the ecosystem in the forests. So, and they're all the non-natives. Now, it was generally hypothesized that earthworms were all non-native to the United States, but that's incorrect. A lot of them came over from ships. They would have them in ballast to balance out the weight of the ship, and then they would just dump everything off. Another problem is when people go fishing and they go out in riparian areas and they go fishing in streams and they just cast off whatever worms they have there, that's another part of the problem. And the reason why they cause that problem is that they're taking a lot of the detritus, the leaf debris, where a lot of the root systems, the ferns, that will be there as well, and they have taken that away. And because they're grabbing this material and they're bringing it and burning it down, which is, in that sense, is good for the soil, but in its proper ecosystem. But that's essentially, when used properly, vermicompost is a fantastic way to inoculate.
We're going to have to cut this off now. If you could come up and talk to him after the meeting, that'd be great. Thank you very much, Jerry.